Okay, we're going to continue from our transformations. All right, but before we learn our new thing real quick, one of our lessons and sections does have one last thing about reflections. Okay, so let me just tell you this last thing about reflections, because they were really hard last time, so just make sure you're listening. All right, but when reflections happened, okay, what happened with them? Like, what did it do? Yeah, it just flipped it over the axis, or it flipped it over the line that we are given. Okay, so let's say that we have a graph like this. Okay. Okay. So there's going to be sometimes you might see some examples where it says, all right, Adam, what did I say to do with your computer? That's what I thought. Okay. So you're going to have some reflections that's going to say y, it's going to be reflect over the y equals x graph. Okay? So what that's going to look like is it's going to look something like this. Okay? Where it's talking about this line right here. All right? So maybe you might have an image like you have a square right here, okay? And it reflects and it's going to be this square right here. Okay? What happens when you have your y equals x is when you have the x, y, okay? All that changes is for your coordinates, okay? It's just y, x. It just flips. Okay? Why did that not write on the bottom? Awesome. No, but I wrote it on the computer, so it'll show up in a second. Stop doing that. Okay, so I'll just have to write it on the board. All right, but it's just going to be x, y, okay, and it just becomes y, x. Oops. Just like that. So make sure you get that written down while I try to fix this. That was just like my image. It was reflecting over that line. Like it was like the polygons that we had when they flipped. That was my polygon. Okay, this was when, ooh, perfect. There we go. All right, it showed up. Okay, so as you can see, all right, x, y, all right, becomes just yx. So those numbers just flip. Okay, now for reflections, there's also a y equals negative x line. All right, so with that, I'm going to draw my coordinate here. Okay, this line is just doing like the opposite. Okay, so just think of this as like the slope-intercept form. Like when we have y equals x, all right, that's just rise over run 1 over 1. So that's what's happening right here on the first one. This is like y equals negative x, so that's negative 1 over 1. So our line goes like this. Okay, so it goes down 1 over 1, down 1 over 1. All right, so this is our y equals negative x. And what happens with our x and y here is we have our x, y. Okay, what happens is it becomes negative y, negative x. Okay, so like if I had this coordinate right here that was 2, 2, or 2, 2 is a bad example. Let's say I have this coordinate right here, which is 2, 1. Okay, and I need to reflect it over the y equals negative x line. All right, what would my new coordinate be when I reflect over that line? This is 2, 1. Negative 1, negative 2. So it would be right here. Okay. Yep. X and Y flip, and then they both become negative. Or if it's negative, it becomes positive. Okay? That's with reflections. That ends reflections. Now let's go to our new topic. All right? We're still continuing with transformations. Now we got rotations. We're rotating today. It's fun. Okay? So when we rotate, okay, pretty much every time it's going to say counterclockwise. So pay attention to counterclockwise. All right, so when we go counterclockwise, like what is it? Is it going to the right or left? Yeah, it's going to the left, okay? So Pay attention here. We're going to talk about 90 degrees counterclockwise first. Okay? So these are all counterclockwise. All right? When we have 90 degrees and we have our coordinates of x, y, it becomes negative y, x. Okay? So negative y, x. So if I had the coordinates of 3, 2, what would my new coordinates be? Negative 2, 3. Perfect. Okay? That is 90 degrees counterclockwise. 180 degrees. All right, counterclockwise, or this is also 180 degrees clockwise. All right, it's going to be in the same spot. Okay, we have our x, y. All that changes is it becomes negative x, negative y. Okay, so negative x, negative y. All right, so if I have the coordinates 3, 2 again, what happens? Negative 3, negative 2. Perfect. Okay. Finally, we have 270 degrees counterclockwise. Okay, and this is going to be y negative x. So y negative x. Oops. So again, if I have 3, 2, what are my new coordinates? 2, negative 3. Okay? This is all counterclockwise. Okay? If I said 90 degrees clockwise, what would that be the same as? Yeah. That's 90 degrees counterclockwise. What if I said 90 degrees clockwise? It would be the same as 270 counterclockwise. Okay? So just know this is the same as 90 degrees clockwise. Yeah. So if we had a coordinate plane, okay, and let's say we had, let's say this was 2, 3, okay, so let's just say it was right here, okay. When we go 270 degrees counterclockwise, it's going to go, this is 90 degrees clockwise, 180, 270. So it's going to land right here, okay. So like if this was 2, 3, all right, with counterclockwise, when we get to this position right here, all right, it's going to become 3, negative 2. You'll see some images and we'll do some examples, okay? Okay, good. I'm glad you understand. It'll tell you. Yes. All right, let's look at some examples. All right, let's look at this one. What is the image of the point 0, 9 after a rotation 90 degrees counterclockwise? Okay, when we have 90 degrees counterclockwise, what happens to our xy? Negative y, x. Perfect. So then what's our coordinates going to become? There we go. That's 90 degrees counterclockwise. Now this says, what is the image of the point 0, 5 after a rotation of 180 degrees? What happens to our x and y here? They become negative. Okay, so what are our new coordinates here? 0, negative 5. There's no such thing as negative 0. Okay, finally, what is the image of the point negative 7, 9 after a rotation of 270 degrees counterclockwise? What happens to our x and y? Okay, what happens to our x and y? That's what I asked. Y, negative x, so what's our new coordinates? No. 9, 7. What is going on? Okay. You'll have examples like that. Let's look at something else. Let's look at this. Yours will look a little different. All right, but you're going to have examples that kind of look like this, okay? Where you're going to have to find, you want to pick a dot, okay? If you pick a coordinate, I'm going to pick this coordinate right here. All right, and this coordinate is 6, 1, okay? It is saying 90 degrees clockwise. Okay, so that means I need to go here, okay, because that's clockwise, so I'm going 90 degrees, going to the next quadrant. All right, when we have 6, 1, all right, what is my next, what are my coordinates for that one going to be? For 90 degrees clockwise. What's the same as 90 degrees clockwise? 270 counterclockwise. So we should get 1, -6. So this point is going to be right here. All right? So like on here, you would need to find each of the points. Okay? Does that make sense? So you're going to do 270 counterclockwise for each of these. So, no. So just pay attention on when it says 90 degrees clockwise or counterclockwise. Okay? What do we do for 180 counterclockwise? It is the same, but what do we do to our x and y? They both just become negative. They don't flip, they just both become negative. Perfect. Yep. You just do the opposite. Yep. All right, you'll have some examples that look like this. Look at number 16. All right, it's going to be multiple choice, and you got to figure out what happens. Okay, so it's saying we're going from this shape A to shape B. Okay, think for a second on which of these answers you think it is. All right, is it a reflection over the x-axis, a clockwise rotation of 270, a reflection over the y-axis, or a clockwise rotation of 90 degrees? All right, is it B or D? Should be B. These say clockwise, so pay attention. Yeah, it goes here. It's B. It's B. All right. Just make sure you read this carefully. This example right here, that's an example of our y equals x reflection. Okay? Because it's this line right here. All right, that's an example of our y equals x. That's why I just said y equals x. No. Okay, the other one. Okay. All right, do we have any questions over rotations? Yes. Yes. All right, that is it for rotations. No, we have to do 3.4. Our next one, done. You want to just set here? I'll take it. Finish? Okay, you're good to go back to class. Okay, so this next one, okay, you're going to see two different words, okay, but this is going to be called dilations. All right, or scale factors. That was just 3.3. We're doing 3.4 now. That was yesterday. I'm thinking I'm going to change tomorrow. We'll get to that. All right. Pay attention to these. Okay, you will need a calculator for this. I'm doing calculator check. Minus 5 points. Layla. Oh. Oops, I clicked the wrong thing. Dilations / scale factors. All right, we're just going to start with examples here. Okay? Well, you shouldn't be on your phone. It should be put away. Put it in your backpack. All right. For dilations, okay? All we're doing is when we have a polygon like this, all right? It's either expanding or it's getting smaller. That's all we're doing. Okay? So pay attention to this, okay, guys? All right. When we have a dilation on this first example, what is the image of 0, -5 after a dilation by a scale factor of 4 centered at the origin? Okay. All we do is multiply both coordinates times 4. So what's 0 times 4? 0 times 4 is 0. What's -5 times 4? There we go. Okay? Were you not listening? All right, let's look at the next one. What is the image of -9, -9 after a dilation scale factor of 2/3? Now, there's 2 ways you could do this, okay? In your calculator, you could literally just put -9 times, and you could do a parentheses 2 divided by 3, and that gets your answer, because that's just 2/3. Oh, I'm sorry. I don't know why I got 2/3. 1/3. Thank you. Okay, you can just put that in your calculator. Or you could do -9 times 1, because that's on top of the fraction, divided by 3. Okay, so what should our coordinates be here? Yeah.
-3, -3.
I just said. You just put parentheses 1 divided by 3. Okay, do those seem pretty easy? All right. That's all you do for the scale factors. Now pay attention to these when you're given images, okay? So, do you see, this says quadrilateral PQRS is dilated by a scale factor of 1/2, okay? From to form quadrilateral PQRS, okay? So do you notice when it gets the new image, it adds these commas after the letters? They're not commas, but that's just telling us it's the new figure, okay? The new figure, all right, has these not parentheses, apostrophes. Thank you. Okay. Yeah, because it just goes to the new image. That's telling us it's the new image. Okay. So you have to pay attention here. Okay, because if you look at this image right here, they all have the apostrophes. So this is the image we already have. So it already multiplied by 1/2. Okay. So we need to find the previous image. So what do you think we need to do? We times it by 2. Yep, so QR is 12, so we need to multiply it by 2 to get that original figure. Okay? Because we just divided by 1/2, so now we're doing the opposite 2. So really, just flip the fraction. That's what you do. Okay? Does that make sense? This is the new figure. All right? So we're finding the previous one. So it already did the scale factor of 1/2. So it already multiplied by 1/2, and this is the result. So we need to do the opposite. So this time we're going to multiply by 2 to get that original figure. So to find QR, since QR is 12, we times it by 2, and what's 12 times 2? So that's our answer. Okay? All right. I'll have you guys do those problems on your own. I'll give you the rest of class to work on your homework.